Okay, first question. Using this graph, we are going to identify if on any interval graph is increasing, decreasing, or constant. Okay, let's mention that a graph is starting from this point with coordinate 2 and 1. Okay, and it's running all the way to, since we have arrow, that means it's running to infinity, right? And it's increasing. So yes, at this case our graph is increasing. Now how are we gonna mathematically express? So increase or decrease interval identified based on values x. So we need to take the identify the value of x at the beginning of point, which in this case we have 1, and ending point, since the arrow is running to infinity, is going to be infinity. Therefore increase is going to be 1 comma infinity. First we put starting point and then ending point. Okay, next, decreasing. Does this graph has any decreasing area? No. So we write down not applicable. There is no decreasing. Constant, not applicable. There is no decreasing. I mean, a constant. There is no constant here. Yes? Okay. Moving to question number 2. So here we don't have any arrow. We have graph is starting from the coordinate -3 and 5, and graph is ending at the coordinate of 3 and -2. So is this line is increase or decrease? It is, of course, it's decrease. It's because it's just walking down the hill, right? So it is decrease. What's the starting point of x? Remember I said we identify the interval, be it increase, be it decrease, be it constant. Interval we identify based on starting point of x and ending point of x. So starting point of x is gonna be what for decreasing? It's gonna be -3, yes? Oops, 1 second. And then it will end with +3. Practically it's gonna be on this piece, because entire graph is running on this interval on the x, right? -3, +3. Okay, and we don't have any increasing area here, which means not applicable. We don't have any constant area, which means not applicable. Moving to question number 3. So what do we have on this graph? First of all, let me mark down this. This is +2, okay? And this is, let's say, -1, this point. So what do we have on this piece that running from -infinity all the way till 2, which is gonna be this one, right? It's gonna be what? Constant, correct? Here we have constant. So constant is running from -infinity. Yes, it's running from -infinity. Here is we have -infinity, right? till 2. X is 2. So that's when it's going to be constant. So we write down negative infinity till 2. It's constant. Now starting from point 2 and all the way to positive infinity, the graph is decreasing, correct? Graph is decreasing. So the graph decreased from 2 to positive infinity. Here we have plus infinity. And there is no increase. All right. Question number 4. Let's see what we have here. We have here graph that we are going to identify where it is increasing, decreasing, or constant. Let's see. I think we have here an increasing interval and decreasing interval. So first of all, let's identify increasing interval. So where is it increasing? So the graph is increasing here on this interval, right? And then it's increasing from this point to here. On this interval, it's increasing. Correct? So let's write down. So it's increasing from where? Because arrow is infinity. So it's going from negative infinity, because once it runs infinity, it's gonna go to all the way, it's arrow, it's gonna continue this arrow and cross and go, right? Okay, till negative infinity. So identifying as a negative infinity, all the way till 3, correct? Because it's the value of x increasing till 3. And then, comma, it starts from 4, x value of x is 4, this point right here, 4, and increasing till 5. Okay, now let's look at decrease. Decreasing at this brown color, it's original color of the graph. We leave it the color the same. So it's gonna go decrease from 3 to 4, right? And then it's gonna go from 5 to infinity. Again, interval we identify based on x. So from 3 to 4 is decreasing right here. Yes? And then it's decreasing again from 5 to infinity. But x is running to positive infinity, obviously. And there is no constant here, so it's not applicable. All right. Moving to next question, question number 5. What do we have to do with question number 5? This is a graph, y is equal 3x plus 7, and we need to identify whether the graph of this equation is symmetric with respect to the y-axis or the x-axis or the origin. So we need to find out, again, if the graph of this equation is symmetric with respect to the y-axis, x-axis, and the origin. So here we are going to do some drafting. When we have symmetric, the graph of equation is symmetric with respect to y-axis, Let me use different color here so we can identify. Okay, let me see this color. A little bit better. So when it's symmetric with respect to y-axis, then for every x, y point is matching negative x, y. Why is that? I would like to move this a little bit further so we can have space. Because if I have the graph symmetric to y, meaning, let's say here it is. Let's say I have a graph symmetric to y. See? Which means symmetric to y. That means we have y the same, but x is gonna be negative and positive, right? There we go. We have x different, but y stays the same. Yes? Okay, next. We have to identify symmetry in respect to x-axis. When we have symmetric to x-axis, how it's gonna look the graph? Let's say like this one. Yes? This is our x. So what is gonna be in this case? X is gonna be the same, right? X is gonna be the same, but y is gonna be positive and negative. Yes? Okay. So for x-axis, we will have for every value of xy, it's the point will match to x negative y. So y is changing in this case. All right? And in respect to origin, there are three choices: x, y, origin. Let me move this down. In respect to origin, see that I shouldn't have prepared all these examples. Now I don't have enough space. Let me move this. And I prepared because one of the students said that this clicking noise, I guess it's bothering. So I prepared so I have less clicking. But sorry, it's not working. I have to type right during the video, so I have enough space when I need. So, or I can do this. 1 second. Okay. This one now. Never mind, will fit in. So if it's origin, when do we have symmetric to origin? Here is example. See? Symmetric to origin, which means we will have for every x and y, we will have negative x, negative y. Which means, look here, if I take this point here, x is positive, y is positive. If I take symmetric point here, let's say, my x is negative, y is also negative, right? Okay, but if none of them does match, then it's gonna be none. So in some cases it's gonna be none. We'll find out. Okay. Let me see. I want to move this one down also. Okay, we squeezed in. No problem. Let's check it. How are we going to find out? How are we going to check it? The following way. So let's say I have x and y, right? We have x and y. Let's plug negative x. If I plug negative x, I want to see if I get y or not, same y or not. So if I take y is equal 3 times negative x plus 7, I am testing this x, you see? I have x, now I'm plugging negative x. I should get the same y, correct? Which means I should get the same equation. And that is equal, y is equal negative 3x plus 7. Which means this is not y-axis, right? It's not going to be y-axis because this y, original y, 3x plus 7, it's not equal negative 3x plus 7. Checking next one, x-axis. So in this case, if I plug negative y, I should get the same x, correct? Okay, let's see. So now I'm plugging negative y. This one we are done. Plugging negative y is equal 3x plus 7. So if I divide by negative 1 here, negative 1, I'm getting y is equal negative 3x minus 7, which again, we don't get the same x, which means this the equation we got does not match to our original one. So, which means it's not symmetric to x-axis. Now we need to check by origin. Let's check by origin. Let me see. If I check by origin, that means I'm going to take negative x, then I should get negative y, right? So I'm going to replace negative x with negative y and see if we get the same equation. Okay. Our original one is this. Let me change the color so we won't forget. So y is equal negative y actually is equal 3 times negative x. Why? Because look here, it's changing an x and changing y also. Therefore, I'm plugging both. And plus 7. Let's see if we get the same one. We get negative y is equal negative 3x plus 7. If I divide by negative 1, negative 1, negative 1, yes, I'm going to get y is equal 3x minus 7. So on the top I have 3x plus 7. Here I have 3x minus 7, which means doesn't apply neither of them, right? Which means this equation, the graph of this equation, y is equal 3x plus 7, is not symmetric towards to y-axis, to x-axis, neither origin. And indeed, let's see, this is basic linear equation. If I graph if this is point plus 7, so the graph, let's say, it's gonna, oops, the opposite, hold on, messed up. It's gonna go the opposite direction, like this way, positive, this is 7. And indeed, it's not symmetric to anything, yes? Which is very true. Okay, now let's do number 6, same way. X squared plus y squared equals 17. Question number 6. So for number 5, we are answering. Answer is gonna be no symmetric. Okay, now this format, let me clean this, and this template I would like to take into frame. Let me see. We need to take bigger one. Okay. There we go. So you can use this template. It will be right in front of you. So we are going to use the same thing to number 6. Using to number 6. All right. Well, let's see what we have. Let's check to y-axis. Okay. Checking to y-axis. Let me move this down because I will need all area I have. All right, checking to y-axis, which means my x is changing, right? For y-axis, I have x and then negative x. So plugging positive x, negative x, I have to get the same equation. All right, let's plug. Negative x squared plus y squared equal 17. So, or that's mean negative x to power 2, it's going to be positive x squared, yes? X squared plus y squared equal 17. If we compare to original one, we get identical. We get identical. Why this y didn't? That's funny. I can do... Well, whatever. It's not taking color this way. I will enforce to color. There we go. So we got the same, right? We got the same equation, which means this the graph of this equation is symmetric to y-axis. Now, if it's symmetric to y-axis, it doesn't mean that it cannot be symmetric to x-axis or origin. So we keep checking further. Now we need to check x-axis, symmetric to x-axis. So here we have y changing, right? With negative y. So I'm plugging negative y here. X squared plus negative y to power 2 equal 17, which means x squared negative y to power 2 will be positive y squared equals 17. Bingo, we get the same graph again, same equation, which means we have x-axis also here. And lastly, let's check by origin, which means I'm taking negative nx and y because both of them are changing. X is changing on negative x, y is changing on negative y. So let's see, negative x squared plus negative y squared is equal 17. Okay, so we get x squared plus y squared equals 17. Voila, we get all three cases. This is also symmetric to origin. Now, aren't you curious what kind of graph is this? That is n-symmetric to y-axis and symmetric to x-axis. I would. So this is how this graph would look like. That's a formula of circle. That's a formula of circle. See, it's symmetric to x, right? This piece here and this piece here, and also this to this, right? Symmetric to y, like this, and then this and this, symmetric to y, and symmetric to origin also, if you take this piece, or this piece with this piece. So that's, and this is a x squared, actually x squared plus y squared equal 1 is a formula for circle with the radius 1. Now here we have 17, so it's usually 1, we understand 1 squared, so radius is 1. If we here is 17, the radius will be square root of 17. All right, so that's why. Okay, we figured out. Moving to next, we are moving to question number 7. Moving to question number 7. Let me make this more interesting. Instead of 2, I'm going to take it 3, because we already had square. And we'll see how it's what result we are going to get using this template of symmetry. So to check for y-axis, I'm taking negative x, right? Because x is changing for y-axis. Negative x. So y squared is equal negative x cubed plus 8. Now, what is interesting, negative x to power 3 is negative x cubed. Because we have odd degree. When degree is odd, then it keeps the sign. Okay, so the rest is going to be y squared is equal negative x3 plus 8, which means no x symmetry. Next, checking, y symmetry. Checking on x symmetry, I have to plug negative y because y is changing, right? So if I plug negative y power 2 is equal x cubed plus 8. So I guess you are guessing, you can see that it's going to be x symmetry because y is squared. We will get y squared is equal x cubed plus 8, which is bingo. We are getting original equation, graph of original equation, which means we have x symmetry. Oops. All right. And lastly, if we check by origin, obviously it's not going to be symmetric by origin because 1 is 2, 1 is 3. This cube is going to get negative, but y is going to stay the same, right? Because it's square. So from here we can say no origin symmetry. Okay, so we have only here only X symmetry. Okay, all right. Moving to question number 8. This is this graph, question number 8. Let's see what we have to do here with question number 8. With question number 8, it's now we are going to identify symmetry based on graph. So what you can say, it's symmetric to X or Y. It is symmetric to Y, correct? Okay, it's symmetric to Y axis. Okay, now the other thing also, the graph can be odd, even, or neither. So how we are going to identify if it's odd or even or neither? So for odd graph, okay, let me write down. For odd, so f of negative x supposed to be equal negative f of x. I'll explain in a minute. For even, we should get f of negative x is equal f of x. All right. And then if none of them satisfy, then it's neither. So one thing we need to remember, every time the graph is symmetric to y-axis, it's gonna be even. Why? Because I'm going to get, if I take negative point here, see, what do I have? What is my point here? Negative 1. So coordinate here is negative 1 and 0, right? Here is positive 1. So I'm getting positive 1 and 0. This is what even means. Negative x equal to the graph of positive x. So negative 1 has y 0. Here is also positive 1 has y 0. So when graph is symmetric to y-axis, obviously it's going to be even. When it's even, let me take any point here. Like let's say, let me take this point here. Another point right here. So obviously x is going to be positive and negative, right? But the y is going to be the same. F of x, nothing else but your y. So you plug negative x and then you plug positive x, but the f of x, meaning y, it's going to be the same. So let's say if this is negative 2, this is positive 2. So you're going to get here for this point, you're going to get negative 2, 2, and this is what? Positive 2, okay. Positive 2, and here you get positive 2, this one, and positive 2. So pay attention, x is negative, x is positive, but the graph, the y is the same. Okay, that's what we say. So one more time, when x is, when graph is symmetric to y-axis, then the graph is even. Okay, now you will ask me, when is the graph is odd? So here we have y positive on the case of odd. Y here is positive. Y here is negative when x is positive or negative. Okay, negative x become positive x. Look, negative x become positive x. Positive f becomes negative f, which means when graph is symmetric to origin. Okay, then you get odd one. Let me clean this mess. Okay, now I will put this also in the okay, this template so you will know. So in this case we have graph is symmetric to y and it is even. Okay. Moving to question number 9. For question number 9, we need to identify whether the function is even, odd, or neither. And then identify the symmetry of the graph for this function. Okay, so what do we have? How are we gonna identify? This is the template I gave you right away. Okay, that's true. But now I'm going to show you the shortcut, which means once you plug in, you will get the answer. Do you see the degree here? Odd 5, and here we have 1 automatically, right? So degrees, both degrees are odd. When all degrees of all x's in the equation are odd, that means this function is odd. Okay, and for the when it's odd, what did I say? Remember a while ago, when function is odd, which means it's this one, then it's symmetric to what? It's always symmetric to origin. Question number 10. Well, this is interesting case. Here we have even and here we have odd. When we have mismatch, either an odd, that means this function neither even nor odd. So we just put it just like that, neither. If it's neither, then it's not symmetric. It's not symmetric to y-axis, it's not symmetric to x-axis, it's not symmetric to origin. So it's symmetry. Neither. So no symmetry there. Question number 11. Now you tell me we have degree 6 and we have degree 10. Of course it is even. If it's even, what axis is going to be symmetric? If it's even, let's look here. it's gonna be symmetric to y-axis, even graph. Why? Because the y is gonna be the same. See here we have f of x, f here plus, here also plus. Only x is different, yes? Okay, that's what even means. So, 1 second, let me clean this. Okay. Let me clean this piece also. So when we have x is a different sign, here x is different, positive x, negative x, and y is the same. That's when it's even. And it's always going to be symmetric to y-axis if it's even graph. So it's symmetric to y. Question number 12. So we have degree 4, we have degree 2. Is this odd, even, or neither? Of course it's even. Both of them are even, so it's even. If it's even, then it's symmetric to y-axis, yes? Okay. Moving to question number 13. Let's see what we have. Question number 13. Now, this is we are going to answer everything we learned on bunch of questions. Let's get going. We are going to identify the domain. Do we have here interruption of x on the graph? We don't have interruption, right? And both ends have arrow, which means x is running, which is domain, is running from negative infinity to positive infinity. So domain is identified by x. So from negative infinity to positive infinity. Here is running to negative infinity. This one is running to positive infinity. So it's changing from negative to positive infinity. Now regarding range is represented by y. So we have y minimum, it's starting from here, which is 0, right? Y is 0. And it's going to positive infinity, right? It's increasing. So it is going to be, range is going to be square bracket because 0 is included, correct? It's on the graph, 0. And it will run to positive infinity. Okay. At what point now we have zeros? What are the zeros of the function? Okay. What value of x has, it's sitting on the 0 for y. So at this point, if we look at this point, this is where our y is 0. What x is matching to this y? Well, let's assume it's 1. So 0 is matching to 1. X is equal 1, right? Okay. Next. Question number D. Let me see. I think I messed up here. I need to find out Y-intercept. Let me fix it. Yeah, we need to find Y-intercept, and it's much more interesting. Y-intercept. We need to find at what point Y, let me form this way. When x is equal 0, how much is y? Because y-intercept is the coordinate when x is equal 0. Where do we have x is equal 0? Right, this point. This is our y-intercept. And where is it? How much is it? 1, 2, let's say it's 3. So y-intercept is at point 3. So as a coordinate, I can put x is 0, y is 3. Or sometimes my MATLAB is asking just to plug 3. Next, let's identify at what interval the graph is increasing. Where do we have graph is increasing? So let's see, the graph is increasing on this side, right? On this piece. Right here, graph is increasing. So increase, we identify the interval identified based on x. So it's starting from 1 and it's running to positive infinity, correct? Okay. At what point graph is decreasing? Graph is decreasing from this point and to here. So where point is right here, how much is my x? It's 0, correct? So graph is decreasing from 0 all the way to 1, correct? From 0 to 1. Although we see here 3, but that's y. And increase or decrease of the interval is identified by x. And at this point of y is equal 3, my x is 0. That's why I plug 0. And it decreased till 1. Okay. Although we don't have here equation of constant, but we can easily identify where is it constant. Constant is going to be, let me put here comma and identify. Constant. It's x from negative infinity, right? Till 0. We have their constant. Yes? All right. Next. Question number G. For what values of x we have f of x less than 0? Do we have f of x? It's our y, correct? Do we have negative y? No, we don't have negative y. Our entire graph located in the area of positive y. Therefore, this is not applicable. Now we need to look our relative maximum or minimum. At what point of x we have maximum and minimum. Do we have maximum here? No. Why? Because it's going arrows. It's one is running to negative infinity, another one is running to positive infinity. There is no curve going down. But we do have, let me see, we do have minimum right here. Yes? This is a minimum and it is at the point of x is equal 1, right? So this is gone. We don't have maximum. We have minimum, which is going to be at the point of 1. Now, question number I. For what value of x, f of x is equal 4? F of x, which means it's y. It's asking if y is equal 4, how much is our x? Okay, if this is 3, so let's assume this is our 4, and the graph, I can't stretch it. Hold on. Okay, and put the arrow here. So if I drop down, this is 4. F of x is 4. So if I drop down, how much it's going to be? 1, 2, approximately 3, right? Okay, so it's going to be equal, when f of x is equal 4, then x is equal 3. So at the point of 3, f of x is equal 4. All right, now it's asking f of 3, which means when x is equal 3, what about my f of 3? Well, meaning y is going to be positive or negative? Well, since we already have here x is equal 3 and y is equal 4, is it positive or negative? 4 is positive. So we are scratching this negative and we will have is positive. Okay? So we are done with this question. Moving to question number 14. Let's go to this one here. So yet again, this is, let me see. Okay, it's gonna be 1, 2, and 3. 1, 2, 3, and this is 4. Okay, let's see what we are going to figure here. Domain. Since this graph is doesn't have any ending, right? It's keep going. So domain is going to be from negative infinity, but it's going to finish at the point of 3, because that's where the graph is ending. This full this circle, filled up circle, it's going to be 3. And we put square bracket because the circle is filled up. If it would be like an empty circle, then we would put negative infinity to 3 parentheses, because empty circle meaning this point is not included on the graph. Okay, range. What is happening to the range? Its range is y. So we have y, it's in negative, right? This is my negative. We have graph on negative y, and it's changing, going from negative y till 4, correct? So negative infinity, because here it's no end, right? It's coming from negative infinity all the way till 4. And 4 is on the graph included. We put square brackets. Next, zeros. At what point we have x, at what point of y, at what point of x my y is 0? Okay, which means we need to find our x-intercept practically, which is going to be what? It's going to be at this point, 3. And it's going to be at this point. To find out this point, let's see, what do we have here? 1, 2, negative 3. Okay, zeros are negative 3 and positive 3. Okay? Next. How much is f of 4? So x is 4, right? Well, I don't have here 4. It's ending with 3. At this point, let me change. I'm going to change and pick up 2. So I would have here value of y. If this is 2, if I go up to here, it's going to be 3, right? So it's going to be equal 3. All right. Next, we are going to see where it's increasing. So this is my negative infinity. Yes. At what point, till which point my graph is increasing? So let's see. It's increasing up to here. Yes? Which means increase is going to be from negative infinity, right? X is negative infinity. Oops. Why did I clean? Negative infinity, and it's coming to where x is equal 0, right? Okay. Decrease is going to go from 0 till when? Graph is decreasing. This is this reddish brownish color. Decreasing till 0, right? On this piece. Correct? It's increasing on this area and decreasing in this area. Okay. Let me clean so it won't create pseudo impression that that's also part of the graph. So decrease from 0 till 3. Okay? All right. What is next? So next is going to be for what value of x we have f of x less equal 0. For what value of x we have f of x is equal the less equal 0. Okay, well, let's see. Where is my f of x is less equal 0? F of x is my y, correct? So it's getting 0 on this piece. I mean, it's less equal 0, right? On this piece. That's where y is less than 0, correct? Which is going to be from negative infinity till x is going from negative infinity till 3. Yes? Okay. Let's write down. Negative infinity till negative 3. Because we are using the value of x. It's asking for x. Right? Negative 3. Do we have anywhere else? Yes, at the point, because it says equal also. So at the point of 3, my y is equal 0, correct? Therefore, I'm going to put the sign of union and I'm going to put as 5. Only 0.5. There is no interval. Because at the 0.5, y is equal 3. Negative infinity, negative 3, which is this one. My y is negative, right? So we took this piece. And because we have to watch for y is equal 0 also here, equals 0 also, then at the point of x is equal 5, my y is 0. That's why I marked down 5 also. Next, looking for, it is h, relative maximum or minimum. What do we have? We have maximum or minimum, guys. Our point is going to be this one, and this is going to be our maximum, right? So, and it is going to be at what point? What do you think? X is equal 0. The point x is equal 0. So we have maximum at the point x is equal 0. Okay. Question I. Question I is asking us to find out when f of x is equal 4, I'm going to change f of x. Oh, yeah, we have 4. Well, it's constantly, well, okay, let it be. When f of x is equal 4, how much is our x. So f of x is equal 4. It's right here. How much is our x there? 0. So we put x is equal 0. Okay. What else do we have? J. F of 3 is asking positive or negative, which means it's asking when x is equal 3, the y will gonna be positive or negative. Let's look. In my case, it's not gonna be positive or negative, it's gonna be 0. So not applicable. But if it would ask, let's say, f of negative 1, which is here, negative 1, f of negative 1, then the y for negative 1 would be positive because going up. Yes? If it would ask f of negative 4, then it's gonna be negative because y would be negative there. But for the point 3, it's neither positive nor negative, so it's not applicable. Okay, we are done with question number 14. Moving question number 15. It's a little bit long, but I'm pretty sure it's very helpful. Question number 15. Okay, here it says find difference quotient of f, which means difference quotient. Difference quotient is, let me write down, f of x plus h minus f of x over h. And where h cannot be equal 0, because division by 0 we cannot stand, because our fraction will be division by 0. All right, so what does that mean? So in one case, I'm going to take f of x the way we have, okay? And in another case, I am raising x by h. Not value of h, just h. We are not given any value of h. And we're gonna see what result we're gonna get. Let me do it. So how it's gonna look like, f of x plus h is equal f of, okay, let me see. It's gonna be equal 6 times, instead of x, I put x plus h because I'm giving increase to x, and plus 3. So this is my f of x plus h. And f of x we have. Now I can apply the formula. Not formula, but template, I would say, form. Okay, so f of x plus h is going to be 6 times x plus h plus 3 over h, and then minus f of x, right? So minus f of x minus 6x plus 3. Okay, what do we get here? So I'm getting 6x plus 6h. I am distributing here, plus 3, minus, since negative I have in front, will minus 6x minus 3 over h. So plus 6x minus 6x, canceling each other. Yes. We have plus 3 minus 3, canceling each other. And we have left 6h over h, where h is also canceling, and the result is 6. So that is the answer. So this is the difference quotient of f. And we will solve one more difference quotient of f for this one. So I'm going to apply same for the template f of x plus h minus f of x over h. So how much will be f of x plus h? It's going to be negative x plus h squared plus 7x plus h and plus 3. So pay attention, everywhere where I have x, I am plugging x plus h. Okay? All right, so I need to open this x plus h squared. I can apply formula. There are two ways. One way to apply formula, a plus b squared, which is going to be a squared plus 2ab plus b squared. Or you are going long way and you just multiply x plus h times x plus h. I'm going to go use this formula. So f of x plus h is equal negative. So I'm going to get x squared. So instead of a, I have x, right? So it's going to be x squared plus 2 times ab. My a is x and b is h. It's going to be 2xh and plus b squared, which is going to be h squared. And continuing writing down 7x plus 7h and plus 3. Now let me open this negative sign in front of parentheses. It's going to be equal negative x squared minus 2xh minus h squared plus 7x plus 7h plus 3. We have it now. Anything we can simplify? No, nothing. Everything is going to stay the way it is. All right, so let's apply this template. So it is going to be, so f of x plus h, which is this one, negative x squared minus 2xh minus h squared plus 7x plus 7h plus 3. And doing minus, I have here minus f of x, right? So it's going to be minus negative x squared plus 7x plus 3. This original one, right? We plug in. Okay, and all this we divide by h. Let's do it. Negative x squared minus 2xh minus h squared plus 7x plus 7h plus 3 plus x squared, because we have negative sign in front of parentheses. So it was negative x squared will become positive minus 7x minus 3. And all this we divide by h. Okay, I have negative x squared and positive x squared. It's gone. Next, I have plus 7x. I have minus 7x. It's gone. What else do I have here? I have plus 3, I have minus 3, right? So let's see what we have left here. So we have left negative 2xh minus h squared plus 7h. over h. Look at that. In numerator, every term has h. So I'm taking out this h. Why? Because I have in denominator also h. I can get rid of it. Will be negative 2x minus 1h plus 7. Right? Once I take h out. And here I have h. This is canceling. And the answer is going to be negative 2x minus h and plus 7. Seems long solution, but we made it. Okay? Here it is, number 16. Okay, I'm done. So thanks for watching, and I'll see you at the next video.